Okay, the topic that we are going to discuss is about the second application of first order differential equations, which is exponential growth or decay. So, there are substances that decompose or increase, and the rate of decomposition of a substance proportional to its amount is what you call the exponential decay. However, the opposite of that is what you call the exponential growth. Okay, and let's say S will be representing the amount of a certain substance which follow the law of exponential change. Okay, so therefore we have the rate of the change in the amount S is ds over dt, and that will be equal to k times S. Okay, so k here will be the constant of proportionality. Okay. Now, let's have an example so that we could apply dE, okay, in the exponential growth or decay. So, example, radium decomposes at a rate proportional to the amount present. In 100 years, 100 milligrams of radium decompose to 96 milligrams. How many milligrams will be left after another 100 years? And what is the half-life of radium? So our S here represents the amount of radium. Now as stated in the problem, it undergoes decomposition. So there is exponential decay that is happening or occurring on the amount of radium. Okay, and the next sentence states that the change from initial amount of 100 milligrams, it changed into 96 milligrams, and that occurred after 100 years. Okay, and now we are asked to determine that after another 100 years, by how much amount of radium will be left. Okay, so but before we proceed to this next question, we shall have apply dE first. So we know that the change in the substance S with respect to time is equal to K, which is a constant of proportionality, times the amount or the initial amount S. Now, this is simple because we could do separation of variables. So you have K, okay, we are going to transfer S here. Then we have K times dt. And you could integrate both sides, and then we have plus C. Okay, let's say this is C1. Alright, so ds over S will have ln of S, or let's just say this is C, just C. Okay, ln of S equals K times T plus C. Okay, and if we are going to raise everything from E, so it would look something like this. Okay, so we have E ln of S, that's S equals E raised to kt plus C, that's equal to E raised to kt times E raised to C. Okay, and let us say that E raised to C is equal to C1. Okay, so we'll have S equals C1 times E raised to K times T. Okay, this now represents the equation by application of first order dE, which is simply separation of variables. This is now the equation that represents the amount of the substance, okay, as a function of the time. Okay, so amount of substance after a certain time. Okay, now C1 here represents the initial amount or the baseline amount. Okay, initial amount or baseline amount of the substance. And then S again is the amount after time t, represented by t. And k here is the constant of proportionality, which defines the rate of change. How fast does it change? Okay, so we'll now proceed to the problem by applying this equation that, or function that we got from separation of variables. Okay, so we have here, in 100 years, 100 milligrams of radium decomposed to 96 milligrams. So this will be consider the initial amount, and this will be the new amount, or that amount that is the result of the change. So if our initial amount is 100 milligrams, then therefore at initial time where t is equal to 0, okay, the initial amount, if the initial amount is 100 milligrams, then therefore the amount at t equals 0 is also 100 milligrams. Okay, because if we have S equals C1 times E raised to K times T, okay, the amount from 100 milligrams, we have E raised to K times 0. Okay, and E raised to K times 0 is E raised to 0, or that is E raised to E raised to 0 is equal to 1. So we have 100 times 1, still S is equal to 100. So therefore, after a time t is equal to 0, okay, at the initial time, okay, the amount does not change. Okay, but if the amount of time is not equal to 0, then we will expect that the initial amount will change to amount S. So that is what we can apply that in this sentence, that after t is equal to 100 years, the initial amount C1, which is 100 milligrams, will change to S equals 96 milligrams. Okay, now this second sentence will help us to get the K constant of proportionality. So again, if we have S equals C1 E raised to KT, okay, our initial amount 100 milligrams will change after 100 years, will change into 96 milligrams. Okay, so with this equation, we will be able to get the value of K, which will help us have a particular solution, because most definitely the K, because of the K, unknown K value, we only have a general solution. But for us to have a particular solution, we need to get the value of K, and this second sentence helps us get the value of K. So in this case, since the variable is in the form of an exponent, if we are trying to use shift solve, actually we would use shift solve. When you say shift solve, you type the full equation. So you have 96 equals 100 times E raised to K. So we'll set K as the variable X, then times T, which is 100. Okay, so if you were able to type all the equation, we will use shift solve. Okay, we'll just press shift, then this button with the word calc, no, na-erase lang yun akin, pero calc nakalagay, wherein at the top of it, there's the word solve. So you press that. After pressing shift, you press solve, and then it will ask, should we solve for K? Then you will press equals. Okay, now take note that if you are going to use, or if you are going to use shift solve, there are times that if the variable is in the exponent, the calculator will load for a longer time. Okay, so in this case we have the answer. K now therefore is equal to negative 4.08 times 10 raised to negative 4. So we could now have the complete solution S equals C1 times e raised to negative 4.08 times 10 raised to negative 4 times t. Okay, so we could now answer the next question. How many milligrams will be left after another 100 years? So we could, there are two ways. First is if our baseline amount or initial amount is still 100 milligrams, okay, this is from when t is equal to 0. Now, after 100 years, okay, C becomes S, which is equal to 96 milligrams. Okay, but we are asked after how much is the amount after another 100 years. So from t is equal to 0, we have another 100, so that will be 200 from t equals 0. So after 100 years, that's 96, and after another 100 years, so from 0 time, that will be 200, no? 100 plus 100. We should determine the amount after 200 years. Okay, if our initial amount is 100. Okay, so we'll have S equals the initial amount being 100. Okay, and then we have E raised to negative 4.08 times 10 raised to negative 4 times T, which is after 200 years after the initial amount 100. Okay, so that will be, okay, we'll have 100 E times negative 4.08 times 10 negative 4, we have 200. Okay, we'll have 92.16 milligrams. Or if we are going to use the initial amount 96, and if let's say for the initial amount 96, t is equal to 0, okay, then therefore the S that we are looking for is after t equal to 100. Okay, kasi po kung ito ang initial natin, okay, yan, at time equals, siya ang isa natin as time equals 0. So we are asked after another 100 years. So if this is the baseline, then after another year, that will be equivalent to 100. The difference with this consideration with the previous solution is that if our baseline is 100, and after 100 years, it became 96, and we are asked what will happen after another 100. So from here, that will become 200. But if our baseline is 96, and that's already happening at the 100th year from 100 milligrams, then if we will use that as our baseline, then the time that we have to set is just 100 kasi ito na yung ating initial. So S equals 96. Then we have K, negative 4.08 times 10 raised to negative 4. Then our T will be only 100. Kasi nag-start na tayo dun sa time na 96 na lang siya. Okay? So, we will still get the same amount, hopefully. So, ito is 96 na siya. And then, this one will be 100 na lang. Okay? So, same pa rin ang answer. So, we will just have to be careful kung what will be our baseline amount or our C1, and be careful what will be the T for that T1 and then T2. Okay. Next, we are asked to get the half-life of radium. So when you say half-life means time required to decompose half of the initial amount. Okay? So, meaning, if we are going to get the half-life, what is the time required wherein from C1, which is 100 milligrams, it will, after time t, it will only, what's left is only half of it, which is 50. Okay, so yan ang meaning ng half-life. So, if we have 50, half is left from the initial amount, 100, and e raised to negative 4.08 times 10 raised to negative 4. Then we are looking for the time. After what time from initial amount will it become halved? Okay. So, could use shift solve again. 50 equals 100 e negative 4.08 times negative 4, then x, variable x for our time. So, we'll shift, solve, then equals. So, pag nasa exponent ang variable, medyo mag-loading ang pero anyway. Alright, so, the result is 1,698.89 years kasi we are asked for the time. And the time here is in years. So, kailangan ito, years. Or approximately, pwede na rin natin i-declare approximately. After 1,700 years, the initial amount will be half. Yan. So, ito yung tinatawag natin na half-life. Okay. Now, before we proceed, ito lang, meron lang akong tip. Kung ayaw nyong gumamit ng shift solve, let's say ito, balikan natin to. Okay, we are looking for the value of k. If you don't want to use shift solve, just transfer. You have e raised to k times 100. Okay, and that will be equal to, we transfer 100 to the other side. So, that's 96 over 100. Okay, and since we need k, we have to put ln to both sides of the equation. Then you have ln 96 over 100. And then what is left is, if you have ln of e raised to it an exponent, then that is just simply equal to the exponent. K times 100 or 100k, and that is equal to ln of 96 over 100. So we could now get k, and that will be ln of 96 over 100, then all over 100. So k will be, tingnan natin kung pareha pa rin ang result, ln 96 divide 100 all over 100. So, still we got the same answer, negative 4.08. Negative 4.08 times 10 raised to negative 4. So, you use this conventional way of getting the variable in the exponent if you don't want, if the calculator loads for a longer time. Okay, so kung dugay siya mag-load ang gamit ang shift solve, mag-ali na lang ka para makuha dayon mo siya. Anyway, let's proceed to the next example. Okay, the population of a certain community follows the law of exponential change. If the present population of the community is 144,000 and 10 years ago was 100,000, when will the population double? In 10 years, what will be the population of the community? So, okay, we need to get the value of k. Now from DE, we already know that S is equal to C1 times E raised to K times T. We already performed DE. But what I want you to do if we are given exercises or tasks, you have to start with ds over dt equals k times s. And you have to perform DE because kasi application of DE tayo. So you have to start from this equation and then you get ds over s equals k times dt and then plus c. Okay, so you have ln of s equals k times t plus c1, raise everything from e. You have s equals e kt times e raised to c, wherein we set this as our c1. So we have s equals c1 times e raised to k times t. So whenever we have quizzes or exercises or what, you have to start from this equation. Do not give this equation right away so that you will be able to familiarize how you got this equation in case you forget. Okay, so you also have to remember this equation. Okay, so present population is 144. Now we are asked as to when will the population be double. So as you can see, if 10 years ago it's 100,000 population, after then present is 144, then there is exponential growth. Okay, so we will expect that as time goes by, the population increases. Okay, so if we are going to set this second sentence here will help us solve for the value of k, because we have s, we could set c1 and we could set t. Now there will be two ways. One is if we are going to set the initial amount as c1, which is 10 years ago population 100,000. So if it is 10 years ago and this is our baseline amount, then therefore t 10 years, so 10 years after this baseline amount, k population becomes 144,000. Okay, so they'll have 144,000, which is s, equals c1, which is 100,000, and e k, and 100,000 population becomes 144,000 after t 10 years. Okay, from the initial amount. So k now will be k 144. Pwede lang kasi 144, divide everything with 1,000, then pwede natin siya i-simplify. We have 100, then you have e x times 100. So you have shift solve, so that k here is equal to, nagloading, tagal. So pag ganito, if you don't want to load your calculators for a bit longer, then you could use manual calculation. But anyway, lumabas na. So you'll have, ano ba to? Have 3.6 times 10 raised to negative 3. So it is, k here is positive. Now if k is greater than 0 or positive, there is population growth. So kanina is decay. So if it is negative or less than 0, then there is population decay. So kanina population decay because k is negative. Okay, now let us proceed. Okay, let me correct, 10 lang pala, no? 10. So ulitin natin, let's recalculate. Mali ang na-type ko dito, kaya pala. So shift solve. So you have the answer. in exponential. That's 36. Or that's, okay. Teka lang. So, it's 36.5 times 10 raised to negative 3. Okay. So, kung pwede, ano natin siya, negative 2 or negative 3 na significant figures. Okay. So, this is the correct value of k. So, we already have the value of k. Pwede din natin siya makuha if our C1, there's another method, if our C1 is 144,000. Okay, now if it is, if S will be 100,000, then T here will be negative 10 because of the word 10 years ago. So, paatras naman ang time. So, if present ang ating initial amount and 10 years ago is 100,000. So, since paatras ang time, so we have negative 10. So, ito yung another solution. So, you have 100,000. You have 144,000. You have E, K, then negative 10. So, we'll get, obviously, we will still get, if you want to check, but I'm sure we will still get the same value of K. So, depends lang, no? So, what will be your initial amount, your C1, and what will be your S. Okay, now, we are asked, when will the population double? So, since our initial amount in the present is 144,000, this is C1, when will it become double? So, that should be 288,000. Double 144,000. So, when? Okay, so this will be our S equals 144 E raised to 36.5 times 10 raised to negative 3 T. So, T, okay, you have 288, 144 E, 36.5, then negative 3 times T. Chip solve. Exponent to siya ha. So, that will be 18.99. Exponent ng T ha. So, E raised to 36 times T. Or, 19. After 19 years, the population will double. Approximately 19 years. After 19 years. Next, last question. In 10 years, what will be the population of the community? So, from present, 10 years from the present population, what will be the new population? So, C1, obviously, is the present, 144. 10 years lang, 10. Okay, then E, 36.5 times 10 raised to negative 3 times 10. So, after 10 years from the present, the population will become 1,000. So, ang 1,000 ani apil na og kuan kay dili naman kanitanan. Ayo siya i-divide og 1,000. Kato ganina, i-divide lang nato 1,000 kay gi-simplify lang nato equation. If we divide here everything by 1,000, what is left here is 144 and 100. Pero pag ganito na, can't divide that to 1,000. Or you can, but you must like put it back. 36.5, negative 3, then you have 10. So, after 10 years from the present, the population will become 207,434 people. Okay, that's it.